Well, hello, my students. Who guessed that snow day? Who guessed that snow day? Of course it was me. I saw it coming. But anyways, we're going to do some more with radicals, and we're going to do variables. Now, I plan to make a review video in about 45 minutes because I want to make an algebra video. So, hoo. So if you want to watch that, it may be sort of fun. So tomorrow's Wednesday. We will have our test on that day. But the question is, how do I take the square root of a variable? Well, really the question is, what am I squaring? Well, when you have a variable to a power, then to another power, you multiply. So what times 2 is 4? And that would be 2. So the square root of x to the 4th, what am I squaring? X squared. So if I had square root of x to the 20th, again, what am I squaring? Well, that would be x to the 10th squared, because when I have a base to a power to another power, multiply, so that'd be x to the 10th. So the rule is just divide the power by the index. So square root I divide by 2. So if I had square root of x to the 30th, you'd say, well, it'd be x to the 15th. You just divide the power by 2. So what if I had the square root of x to the 15th? Got a problem. Because the square root of x to the 15th, 15 is not divisible by 2. But I can break it up to the square root of x to the 14th times x. Because when you multiply two things same base, you add. 14 plus 1 is 15. So it'd be square root of x to the 14th, square root of x. And when you take the radical of a variable, you divide the power by the index. So that'd be x to the 7th. The square root of x I can't do anything with. So if I had square root of x to the 43rd. Well, odd power, can't do it, divisible by 2. So I'd break it up to the square root of x to the 42nd, x. So that would be x to the 21, square root of x. Divide the power by 2. So if I had cube root, x to the 30th. Well, you divide the power by the index. So it'd be 30 divided by 3, because if I wrote it out, it'd be x to the 10th to the 3rd, because when you have a base to a power to another power, you multiply. So 3 times 10 is 30. So it'd be x to the 10th. Now again, if I had to have a power that's not divisible by 3, then I would break it up into the power that is divisible by 3, and then the power that's left over, cube root of x squared. And the cube root of x to the 30th is x to the 10th. Woohoo! Are you getting this, my 8th graders? I hope you're not out covered in snow getting sick. So if I had the 4th root of x to the 40th, you'd say, well, you just divide the power by the index. So it'd be x to the 10th. But again, if you had left over, let's say it's the 4th root of x to the 83rd. Well, I need to break it up into the part that's divisible by 4. That'd be x to the 80th. And the part that's left over. So that'd be x to the 20th, the 4th root of x cubed. So if I had the 5th root of x to the 19th, I'd say 19 is not divisible by 5, so I need to break it up. It'd be the 5th root of x to the, well, what number is divisible by 5 below 19? And that'd be 15. And then the part that's left over. In this case, x to the 4th. because when you multiply two things same base, you add. 15 plus 4 is 19. So this would be x to the third, the fifth root of x to the fourth. So if I said, what's the 10th root of x to the 206? Well, you'd say 206 is not divisible by 10 to give you an integer, so I need to break it up. What is divisible by the 10th? Well, that'd be x to the 200, the 10th root of x to the 6th. And when you have a base to a power and you're taking radical, you divide the power by the index, so it'd be x to the 20, the 10th root of x to the 6th. So what if I had the square root of 8x to the 17? Well, I have to break it up into two parts. The part that is a perfect square and the part that's not. What perfect square goes in 8? Well, that's 4, and I'd have 2 left over. And not divisible by 2, so I'd be x to the 16th, and then the x left over. This is 2x to the 8th, square root of 2x. So if I said, what's the square root of 50x to the 50th, y to the 17th? You'd say break it up into two parts. The part that's the perfect square and then the part that's left over. What perfect square goes into 50? Well, that's 25. And Q. This is even, so I can use it. Not even, so I break it up y to the 16th. Put the y in there. So this would be 5x to the 25th, y to the 8th, square root of 2y. So try these two on your own. Square root of 18x to the 18th, y to the 21. And try cube root of 24 x to the 17th. So break this up into perfect square, not perfect square. Perfect cube, not perfect cube. So turn me off and do it, and then turn me back on. Okay. So what perfect square goes in 18? That's 9. Even power, it's divisible by 2, so bring it along for the ride. And then this is not an even power, so I got to break off a y. I'm sorry, that should be 20. I put 10 by mistake. I read that wrong. I got the 2 left over to make 18, and I got a y left over. So this would be 3x to the 9th, y to the 10th, square root of 2y. This one I need a perfect cube, then the stuff that's left over. So what perfect cube goes into 24? Well, that's 8. 3 is left over. What's divisible by 3? 17 or below? Well, 17's not, 16's not, so it'd be x to the 15th, then x squared left over. So it'd be 2x to the 15 divided by 3 is 5. And then the cube root of 3x squared. Woohoo! Try one more and then that's going to be it. Do the fifth root of x to the 21, y to the 43, z to the 52. Well, you need to break it up. Perfect fifth power, not perfect fifth. So I need something divisible by 5. So this would be x to the 20. Got that 1x left over. Y to the 40. Then I have y cubed left over. And z to the 50. And z squared left over. So divide it by the index. So it's x to the 4th, y to the 8th, z to the 10th, and then the fifth root, don't forget the index, of x, y cubed, z squared. Woohoo! Now tomorrow after the test, I'm going to have a worksheet for you that has all this on it. Tonight, I just want you to study. And I'll have the review thing done in about 45 minutes, I'm assuming. So we'll see. Have a good day.